Determine the polynomial function corresponding to each graph. You may leave your answer in factored form. Identify the zeros of the polynomial and their multiplicities. The zeros of the polynomial are 0 with a multiplicity of 3 and 5 with a multiplicity of 2. Next, we'll set up a template polynomial equation. Write p of x equals a times x cubed times x minus 5 squared. The 0 of 0 corresponds to a factor of x. The multiplicity is 3, so we'll cube the factor. The 0 of 5 corresponds to a factor of x minus 5. The multiplicity is 2, so we'll square the factor. Now use a point on the graph to solve for the leading coefficient a. We know the point 2, negative 6 exists on the graph. Plug in 2 for x and negative 6 for p of x. This gives us the equation negative 6 equals a times 2 cubed times 2 minus 5 squared. Simplify to get negative 6 equals a times 8 times 9. Simplify further to get negative 6 equals 72a. Divide both sides by 72. The value of a is negative 1 over 12. The last step is to write the final polynomial function. The graph is represented by the polynomial function p of x equals negative 1 over 12 times x cubed times x minus 5 squared. Now we'll move on to part B. Identify the zeros of the polynomial and their multiplicities. The zeros of the polynomial are negative 6, negative 2, 2, and 6. All of the zeros have a multiplicity of 1. Next, we'll set up a template polynomial equation. Write p of x equals a times x plus 6 times x plus 2 times x minus 2 times x minus 6. Now use a point on the graph to solve for the leading coefficient a. We know the point 4, negative 15 over 2 exists on the graph. Plug in 4 for x and negative 15 over 2 for p of x. This gives us the equation negative 15 over 2 equals a times 4 plus 6 times 4 plus 2 times 4 minus 2 times 4 minus 6. Simplify to get negative 15 over 2 equals a times 10 times 6 times 2 times negative 2. Simplify further to get negative 15 over 2 equals negative 240a. Multiply both sides of the equation by 2 to get negative 15 equals negative 480a. Divide both sides of the equation by negative 480 to get 1 over 32. The last step is to write the final polynomial function. The graph is represented by the polynomial function p of x equals 1 over 32 times x plus 6 times x plus 2 times x minus 2 times x minus 6.